Welcome to this explainer. We've got a real detective story for you today. We're going to dive deep into the mystery of why the top AI coding models suddenly stopped performing like identical twins. You see, for a long time, the numbers told us one thing, but the reality on the ground was entirely different. So let's unravel what actually happened.
For months, enterprise buyers were sold this really comforting myth that all the leading AI coding models were basically exactly the same. But here's the catch. Developers who were actually using these tools day in and day out knew this didn't match reality. The gap between the models was something you could literally feel every single day. But the scoreboards, they just stopped showing it. So why the massive disconnect?
To understand the problem, we have to look at how these models were being graded. On the previous leading scoreboards, like SW Bench Pro, the absolute strongest coding agents were all huddled tightly together in this super narrow 30-point band. When the scores are compressed like that, picking one model over another looks like splitting hairs. It creates this perfect illusion of total parity across the board. But then, DataCurve dropped a brand new benchmark called DeepSuite, and it completely shattered that illusion. It spread those exact same models across a massive 70-point range. Suddenly, GPT 5.5 is way up at the top at 70%, Claude Opus 4.7 sits at 54%, and Claude Sonnet 4.6 drops to 32%. Same exact models, radically different picture. Now, that shocking scoreboard, that's really just the hook. What we actually need to investigate is the deeper mystery here. Why did the gaps between these models suddenly come back? And more importantly, what does the sudden change reveal about just how badly the old benchmarks were measuring these AI agents in the first place?
Section 1. The crime scene. Investigating the broken grading machine. So DataCurve actually audited the old verifier, and they discovered something wild, a terrifying 32% error rate. We're talking 8% false positives, where completely wrong answers get marked right, and 24% false negatives, where totally correct solutions get marked wrong. This means nearly a third of the benchmark's pass or fail decisions were completely incorrect to anyone reading carefully.
Think about it. When your grading system is basically a coin flip a third of the time, well, of course the models are going to cluster together. An error bar that wide doesn't just add a little bit of noise. It completely erases the actual performance gaps that buyers are desperately trying to see. It literally blurs the models right into each other. And that brings us to an even more uncomfortable finding. DataCurve figured out that the old benchmark was actually shipping its containers with the full .git history included. That means the merged gold commit containing the actual real fix was right there. Resourceful models could just run a git log, find the merged solution, and literally copy and paste it. As the quote perfectly puts it, the benchmark left the answer key in the room and then graded the test.
So just how bad was that loophole? Well, Claude Opus 4.6 ended up passing about 25% of its successful trials literally just by reading the answer out of the Git history. Now, to be fair, we shouldn't just say the model cheated. Being resourceful in a real coding environment is actually a good thing, but it absolutely proves the benchmark was rewarding a loophole rather than measuring true ground-up coding capability.
Section 2. The fix? How DeepSuite cleaned up the measurement.
So how did they fix it? DataCurve brought in 4 core design choices. First, totally contamination-free tasks written from scratch, so the models can't just recall public patches. Second, short prompts that require long horizon work. Third, they varied the code bases, spreading tasks across 91 different repositories so no single project dominates. And finally, handwritten verifiers that test observable behavior with rigorous regression checks.
Now, this part is kind of counterintuitive, but it's brilliant. DeepSuite's prompts are actually way shorter, like half the length of the old ones, but they're super behavior-focused and intentionally underspecified. There's no massive interface definition holding the model's hand and telling it exactly what to do. This forces the agent to actually explore and write over 5 times as much code, which is exactly the kind of end-to-end exploration a real developer does.
And because they used those custom, handwritten, robust verifiers that check for actual real-world functionality rather than just rigid implementation details, the grading improved dramatically. DeepSuite managed to drop the false positive grading rate all the way down to just 0.3%. They finally created a measurement tool where you can actually believe the pass and fail decisions. Section 3. The suspect profiles, uncovering the real model differences. Once you strip away all that noise, you actually start to see these really distinct model personalities.
GPT models, they act precisely and literally on the requirements. They're amazing in doing exactly what is asked. Claude, on the other hand, is highly attentive to the environment. It'll even write its own tests over 80% of the time without being prompted. Though Claude can be a bit forgetful, it occasionally misses a branch when you give it really complex multi-part prompts.
And, these nuanced behavioral insights are exactly what you should be taking away from all this. It shows you the actual shape of a model's strengths, not just some arbitrary rank on a leaderboard. This is the practical, deeply memorable information that enterprise buyers actually need to confidently deploy AI into real code bases. It's a level of detail that a clustered, noisy leaderboard was never, ever going to provide.
Section 4. The verdict. Why evaluation hygiene matters.
Now, before we accept all this as the new gospel, we definitely need to keep a few healthy caveats in mind. DeepSuite forces all the models to use a single, neutral harness rather than the native tools devs actually use, like Cursor or Claude Code. It's also currently limited just to popular open-source repositories. It doesn't cover C++ or Java yet. And importantly, it was created by DataCurve themselves, a company literally in the data business. So trust, but verify.
But even with those caveats, DeepSuite brilliantly proves a much larger point here. Clean data and, frankly, unglamorous evaluation hygiene, that is an absolutely load-bearing foundation for this entire industry. When you've got millions of enterprise dollars on the line routing real engineering workflows through these agents, you simply cannot afford to make your decisions based on a leaky, inaccurate test.
So here's your ultimate takeaway. Don't just blindly buy the cluster. Run the actual work you do. Watch exactly how these models fail in your specific environment, and always ask yourself the hard question. Are you choosing your AI agents based on a corrupted scoreboard? Thanks for hanging out with me for this explainer, and I'll catch you next time.